Next presentation is by Dan Sullins, Hierarchical Ecological Benefits of the CRP in the Southern Great Plains. So take it away, Dan.
Can everybody hear me okay? All right, great. Thank you for the introduction, and thank you all for coming today. So I've got a long title for this talk as well, but what we're really going to be focusing on today is how we can use the Conservation Reserve Program to benefit a grassland-dependent species. And also, we're not just looking at the treatment effects of this patch within that patch, but also how the region surrounding that CRP field and also the landscape surrounding that CRP field might really influence its utility. So if we look here, this is a landscape that you will find in the Southern Great Plains. This is actually in Kansas, and if you look at the bottom right, your bottom right, we're going to refer to that as native working grasslands. So those are your typical rangelands, your typical pastures, and in this case, they're more or less shortgrass prairie. And then what we have highlighted in red, those are your Conservation Reserve Program grasslands, right? So these were formerly cropland. They've been converted to grassland through the CRP program, and they're adding grassland back to the landscape. So it's a very powerful tool that we can use, considering that 46% of grasslands have been lost worldwide, and within the Great Plains, it's estimated that 70% of grasslands have been lost. And I mean, this is pretty obvious, but this is going to be problematic for grassland-dependent wildlife, right? This is a major constraint on how much grassland's available. And if we look at all of our avian species and which ones have declined and how much they've declined since 1970, grasslands have declined at the steepest rate, grassland birds. The fact that grasslands, particularly in the Southern Great Plains, are over 95% privately owned prevents kind of a unique challenge where we need some innovative tools, such as the Conservation Reserve Program, to really make any changes. So just a general background, the Conservation Reserve Program began in 1985. It's converted cropland back to grassland. Over 7 million hectares in the Great Plains have been converted. It's typically not grazed, although it can be grazed when there's an emergency, such as a drought or a wildfire, and producers in the area need some extra forage for their cattle. And although introduced species can be planted in certain portions of the United States, within Kansas and eastern Colorado, native tall and mixed grass species are typically planted. And this is not like a conversion to grassland is not in perpetuity. These are 10 to 15 year contracts typically. And at the end of that contract, the landowner can decide whether they want to keep it as grass, move it to cropland, or use it for cattle grazing. And one thing that's really important to point out, considering that we're in areas that are 95% privately owned, right? There's financial incentives for these landowners to use CRP, which makes it a pretty important tool. So since the use and establishment of CRP, there are several grasslands birds that have been shown to benefit from CRP, right? We're adding grassland to the landscape, so grassland birds are going to benefit. And I think David Pavlaki is going to talk a little bit more about this later. But what we're going to focus on today is the lesser prairie chicken. And the reason we're going to do that is because it's a species of conservation concern, and because we also have a tremendous amount of data on this bird among multiple scales. So shown here is the lesser prairie chicken range broken up into different patches in Kansas. And before 1998, we were really only aware of lesser prairie chickens occurring in this area south of the Arkansas River. In 1998, the lesser prairie chicken went up as a candidate for listing on the Endangered Species Act. Kansas Parks and Wildlife begins surveying areas outside of where they know lesser prairie chickens to occur, and they ended up finding over 215 leks in the shortgrass prairie CRP mosaic. And since then, what we found is that this is where lesser prairie chickens occur at their highest densities, and they've also shown pretty stable population trajectories in contrast to areas south of the Arkansas River. So we know that this is an important area for lesser prairie chickens, and we know that CRP is a beneficial tool to some degree, but we need to point out that CRP is uncertain, right? It needs to be reapproved with each farm bill, which occurs every 5 years or so. And there's also some socioeconomic drivers that can influence whether that CRP is going to last on the landscape after those contracts expire. There's also a finite amount of funding for conservation. So using that finite amount of funding, how can we maximize that as a tool? So we're overall asking how and where does CRP provide habitat? And we're going to look at this at multiple scales at an overall spatial hierarchy and how that influences the presence of this lesser prairie chicken in a CRP field. So regional factors that might influence or drive the utility of CRP for lesser prairie chickens could be climate related. And we're talking about climate, we're talking about things like precipitation averaged over a 30-year period. So we're talking about spatial variation in climate. Also, the surrounding landscape around that CRP may have a strong influence on whether that area is used and how it provides habitat. We know that lesser prairie chickens use different habitats for different life stages, and also that some habitat fragmentation and heterogeneity can influence the utility of that landscape. And finally, the patch requirements within that CRP field, its ability to provide food, cover, and breeding habitat. But even within the patch, we need to think about that hierarchically, right? We need to think about how that patch of CRP can provide microhabitats for nesting, brood rearing, and during the non-breeding season. This is actually a prairie chicken that's getting off a nest. We're really interested in the small scale factors that are influencing that. So when we look at some of the regional climate effects on where a CRP field might be useful for lesser prairie chickens, it's important to point out that in Kansas and Colorado, we encompass a very large precipitation gradient moving from east to west, and it actually decreases 40 centimeters from east to west. I'm going to back up a little bit, but these red blobs, these are minimum convex polygons, and these are study areas where we have captured and marked lesser prairie chickens with VHF and GPS transmitters. We monitored them from 2013 to 2016, and we're going to use that data to really inform this information that I'm providing you today. But along this gradient in precipitation, we see a transition from mixed grass prairie in the far eastern portions where we have some taller grass to short grass prairie in the far western portions. So across this entire gradient, we'd expect that if you place a CRP field along this gradient, it might have a different influence on lesser prairie chickens overall. And shown here is actually all of the CRP fields in this area. We buffered them by 1 mile to protect landowner identity. But what I want to illustrate here is that this is a lot of CRP on the landscape, and it's also uniformly distributed throughout this entire area, which allows us to kind of answer this question and pursue it. In this area, there's over 1 million hectares of CRP. So it's not just a pocket prairie conservation tool. This has the ability to change landscape composition at even regional scales. So what we found, and I'm going to just jump right into the results, was that CRP was 7 times more likely to be used when annual average precipitation was 55 centimeters compared to 70 centimeters. So they were more likely to use CRP in these drier climates in western Kansas and even in southeastern Colorado. And what we think is going on here is that, right, you have greater precipitation in one area and less precipitation in another. If you're providing a CRP field which is ungrazed and you're planting native mixed and tallgrass species, you're more likely to provide that cover that would otherwise be limiting in these drier landscapes. So this ruler right here, this is actually a CRP field in southeastern Colorado. It's got grass that's about 40 centimeters tall. It's providing sufficient cover to conceal this football-sized lesser prairie chicken. So now we're going to go from the regional scale down to landscape structure. And right, shown here, we have all of our native working grassland shown in blue. Everything else is cropland. We come in and put in a CRP. Well, how does the surrounding landscape around that CRP influence its utility for lesser prairie chickens. And what we found was CRP fields were far more likely to be used when the landscape surrounding it was 70% native working grassland. And this is how that graph is shown continuously. We've got our predicted probability of using CRP on the y-axis and the total area of working grassland within a 4-kilometer extent around that CRP field. So we're increasing the amount of grass on the landscape, and also in these areas that are drier in western Kansas and eastern Colorado, we're also increasing the structural heterogeneity of those landscapes, right? We're adding this taller, thicker grass. It's got short grass around it, and structural heterogeneity has been shown to be really important for lesser prairie chickens. And this is a graph that Christian Hagen shared with me that's in press, I believe, or is in progress. And what he's found is that large-scale occupancy at the 15-kilometer by 15-kilometer scale increases with CRP. But what I want you to look at is that x-axis, right? Even with 15 to 20% CRP in that landscape, we're getting a high occupancy rate. So we're getting that heterogeneity, and we're adding something to the landscape that wasn't there previously. So when we zoom in on the patch scale, we collected a substantial amount of data at random vegetation locations within CRP fields and within native working grasslands. And this microhabitat within these CRP patches, we're looking at like a 4-meter radius around a robel pool. We measured several vegetative characteristics, and based upon a resource selection function and criteria that defines nesting habitat, what we found was that within CRP grasslands, about 46% of those points met requirements for suitable nesting habitat, while in native working grassland, only 20% of those points met the criteria. So in these CRP fields, we're increasing the amount of nest habitat on the landscape scale. Does this translate to nest densities? We think so. Based upon our marked birds, we looked at nest locations of our marked birds, and we found that nest densities were greater in CRP grasslands compared to CRP fields, nest densities were greater in CRP compared to native working grasslands. So we've looked at hierarchy of effects on the use of CRP, kind of based on spatial components so far. On this graph, we're tying in some temporal variation. Throughout our window of study, we incorporated a period of extreme drought and also some pretty wet years. And what we found with these data was that lesser prairie chickens were more likely to use CRP during those years of extreme drought. So if you look at this graph, it's showing your drought severity index -4. That's a more extreme drought. We had birds that were more likely to use CRP during that period. And when we had wetter years, they were more likely to use native working grassland. So by providing CRP on these landscapes in western Kansas and eastern Colorado, you're not only providing heterogeneity to provide habitat for a variety of life stages, you're also ensuring habitat among wet and dry years. So in conclusion, we found that CRP was 7 times more likely to be used in areas where annual average precipitation was 55 centimeters compared to 70 centimeters. So right, again, that CRP is more likely to be used in those drier portions of the range. I didn't talk about this. I didn't have enough time to get through this. We did a lot of vital rate estimation and population matrix modeling, and we found that a nest and adult survival did not differ between native working grasslands and CRP. So we can kind of rule out that thought that, well, maybe all these birds are moving into CRP, they're dying, it's an ecological trap. We found relatively the same demographic rates in CRP and native working grassland. So in conclusion, at a landscape scale, by providing this CRP, we're increasing the amount of nests on the landscape, the amount of recruitment at a population and landscape scale, and therefore we're improving the overall habitat quality. And then finally, that last graph that I showed, we're increasing the availability and stability of habitat on the landscape among wet and dry years. So in conclusion, I think, for a long time and for several years, we've thought of lesser prairie chickens as a grassland specialist that's associated with shrubs. And particularly like 30 years ago, you'd hear about lesser prairie chickens. And I guess I was like maybe 2 or 3 30 years ago, but I guess I can't really say that. But, the literature suggests that they were shrubland specialists. They were in their highest densities in the sand sagebrush prairie and the sand shinnery oak country. And I think these areas are still really important to protect, and we need to get conservation action on the ground there. But we also need to think about the fact that lesser prairie chickens have expanded into this area. They're doing really well, and they're maybe doing better in this unconventional, novel system than other places at the moment. So we should also think of them as a grassland CRP mosaic landscape species. And any change to CRP in the future is going to have a strong impact on lesser prairie chickens in this ecoregion and as a population overall. But with a final positive note, because I think it's rare to give a lesser prairie chicken talk with a positive ending, right? This is a very useful tool. It's been effective in the past, and it can be very helpful in the future. And with that, I want to thank all of our landowners and all that have provided financial, logistic, analytical, and even moral support throughout this project. And I was worried that my Texas draw wouldn't let me get to this, but I'm just going to throw this up at the end anyways. So we put all that information together from all those resource selection functions. We also use a species distribution model to figure out where we can target CRP conservation, where we can protect and conserve existing CRP, and where cropland might be a priority to enroll in the future. And this kind of shows where we're at. So with that, I'll turn it over to Charlie.
We do have a couple of minutes for questions for Dan.
Yes.
Yes, so I was wondering in that area around Cheyenne, what are the grass species in the areas where the birds are focused or using?
So that's a good question. So he asked about Cheyenne County, Colorado, and that area, actually that is a pretty unique area where there is a lot of sand sagebrush in that area. And I think Colorado has about 2 leks there that they know about. There might be 15 to 20 total birds there. The grasses that they used there, it was mostly composed of like sand drop seed. There was some big bluestem or sand bluestem, if you want to call it that, and blue grama in that area.
Another question? So what happens in those yellow areas if CRP expires and they don't get re-enrolled?
Well, we're going to lose habitat in those areas, I suppose.
Are there producers willing to keep them in grass?
Oh, okay, good question. Right. So we're working on a project right now. Christian and Megan Bogerts and Bram Verheyen, and we're looking at kind of the likelihood of those CRP fields remaining in grass past the expiration date. So it looks like right now around 60% of those remain in grassland after their contracts expire. So, yes.
Any concerns about diversity having grazing in the changing climate?
Yes, I think that's a really good point. Right. So the question was, whenever you have like a drought situation or a wildfire, the surrounding landowners are allowed to graze and haze some of those CRP fields. So right, we showed that they were more likely to use CRP in these drought periods. Well, what if those are grazed or hayed? I think there is some concern. During our study period, we had a drought, and I think about 30% of them were grazed or hayed during that period, but that's kind of anecdotal. So, yeah.
All right, thanks, Dan.
Thank you.